Alright, it's time to get ready for our Unit 6 test over cubics and cube roots. Number 1, 2, and 3 all talk about attributes. Anytime we see the attributes, we're going to talk about the domain, the range, the x-intercepts, the y-intercepts, the symmetry, and the inflection point, which I'll just put IP, that's the turning point. It's kind of like the starting point, similar to the vertex, but it's just where it changes direction. The cube root of x, if you were to graph it in your calculator, looks something like this right here. The cube root is always horizontal, whereas number 2, the cubic, is vertical. So cube root's always horizontal, cubed is vertical. And so now the domain, it goes forever to the left and forever to the right, forever down, forever up. So both of them are all real numbers, and it's always going to be all real numbers. The x-intercept, it hits at 0. Y-intercept is where it crosses the y-axis, 0. Symmetry is always going to be rotational on 180 degrees around the inflection point, which for this one is 0, 0. Number 2, domain and range, once again, are all real numbers. It's always all real numbers for both of them. The x and y intercepts, once again, it goes through at 0, 0. And the symmetry and the IP. Symmetry is going to be rotational, 180 degrees, around that inflection point of 0, 0. Alright, number 3, how does this graph compare to its inverse? It doesn't tell us to find the inverse. We could if we wanted to, but here's what I do want to see: the f of x and the inverse. And I'll make a table. And again, we'll go through all the different attributes. And so we'll go through the domain, the range, the x-intercept, the y-intercept, the symmetry, and the inflection point. Alright, so I'll go ahead and graph that in my calculator. So we got y equals 2. Alright, so here's what the graph looks like. Again, my domain and range are always going to be all real numbers. The x-intercept, I know it's somewhere between 2 and 3. Not sure exactly where. In order to find that x-intercept, I'm going to go to the second calc up here, second trace. Goes into calculate. The item right there at number 2 that says 0. 0, that's the same thing as the x-intercept. So I'm going to go down to 0. Now it says left bound, so I'm going to go to the left of my x-intercept. There it is. And so I'm press enter. Go to the right. These two lines should track my x-intercept, which it does, and I'll press enter. There's the x-intercept, 2.86. Alright, to find the y-intercept, the easiest way to find the y-intercept is to go into the table. So I'll press second graph, right there, the table. And the x-intercept is where, the y-intercept is where the x value is 0. So when x is 0, the y is negative 125. So negative 125. Then the symmetry again is always rotational, 180 degrees around. This one moved to the right 4 and up 3, so it's 4, 3. Now what we know about the original to the inverse is all the coordinates just switch places. And so domain and range is still going to be the same. My x-intercept was 2.86, so my y-intercept is going to be the 2.86. And the negative 125 will be my x-intercept, so they switch places. And then the symmetry is, again, still rotational, 180. Around this point, flipped 3, 4. So anytime we're going from original to inverse, you just switch your x and y. right. Number 4, find and graph the inverse. I'll show you the shortcut and then we'll also show the work. The shortcut, anytime you find in the inverse, everything in the equation will switch location and operation. And so right now it's cube root, so it's going to change to be cubic. Right now we have plus 3 on the inside. The opposite would be minus 3 on the outside. And right now we have minus 1 on the outside. We'll change to plus 1 on the inside. And so that is the inverse equation. Another way you could have done that is actually showing the work, switching your x and y. And so x equals cube root of y plus 3 minus 1, and then solve for y. So I would add 1 over x plus 1, get rid of the cube root by cubing both sides, and then last step, to get rid of the plus 3, I'll subtract 3 over. And you'll notice these should be the same, and they are. And so if you can do the shortcut method of just switching operation and location, it's a lot faster. And now graphing this, you can either use a calculator. I know this goes left 1 and down 3. So the left 1, down 3. This one is now a cubic, so it's a vertical graph. It's going to go up and down. So I'm going to go right 1 and up 1, left 1 and down 1. And I'll go right 2, and 2 cubed is 8. So 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4. There's my graph. My base points, in case you had forgotten, from my inflection point, if I go right 1, I go up 1, right 2 is up 8. And that's for the x cubed. Number 5, again, we're listing attributes, so domain and range. Again, always all real numbers. The x int, the y int, the symmetry, and the inflection point. Symmetry, again, is going to be rotational 180. Around is going left 2 and down 6. And so -2, -6. And now let's graph it to find those x-intercepts and y-intercepts. 3. Here's my graph. The x-intercept is somewhere between 0 and -1. And so again, we're going to press second trace, go into that calculate, go to the 0, left bound, there's the cursor, right bound. So there's the x-intercept, -0.74. And then for the y-intercept, we'll go to second graph, we'll go into the table. And when x is 0, that's the y-intercept. So the y-intercept for this one is 18. All right. Number 6, find the inverse. On this one, we'll try and do the shortcut. And remember, everything will change location and operation. And so the inverse, this is cube root, and so it's going to change to be cubic. I've got plus 6 on the outside, so it's going to change to be -6 on the inside. This 5 is being multiplied on the outside, so it's going to change to be divided by on the inside. I've got -2 on the inside, so it's going to be +2 on the outside. And multiplying by 1/3 is the same thing as dividing by 3. The opposite of dividing by 3 is multiply by 3 on the outside. And that's the inverse. Again, if you want to show the work, x equals 5 cube root of 1/3 y minus 2 plus 6. I would first off subtract 6. And I'll go ahead and also divide by 5. And so the first thing we do is subtracted 6 over, and we also divided by 5. And then I'm going to cube both sides. And then I gotta get rid of the 1/3. The opposite of multiplying by a fraction is multiplying by the reciprocal. So we'll multiply by 3 to both sides, and then we'll add 2 over. Then we'll add 2 at the end. And so that's the inverse equation, which you'll notice is the exact same thing as I had at the original. So if you can do the shortcut a lot faster, it'll save you some time. Number 7, solving a cube root equation. First thing we want to do is get this radical by itself, and so we'll divide both sides by -3. And so cube root of x plus 4 is equal to -27. And then we'll cube. The opposite of cube root is cube both sides. And so -27 cubed is -19,683. And then we'll subtract 4 on both sides to get x equals -19,687. It's always good practice to check your work. And so I'll take that x and I'll plug it into my original equation to see if it does equal 81. And so -3. To find the cube root, you go to math, which is right below alpha, right there below alpha. Press math. And we'll go down to that 4th option. And so -19,687 plus 4. And it does equal 81, so this checks. That is the correct answer. All right. Going on next one. Again, we're relating the original to the inverse, so I'll make my columns. We've seen several questions like this, so it's probably going to show up on the test a couple of times. Make sure you're good with all this. Domain and range, again, is always all real numbers. I'll fill that in. I'll go ahead and start putting this in the calculator so I can graph while I fill in some of the other stuff. So I've got 3x minus 1 plus 4, and so while that's graphing, x-intercept, y-intercept, the symmetry, and the inflection point. Symmetry is rotational 180 degrees around. This one goes right 1 and up 4, so 1, 4, which means this one's going to be rotational 180 degrees. And it's going to flip and become 4, 1. All right, so this one, I can see my x-intercept is really, really close to the origin. And so I'm going to go again, second trace, go down to that 0, left bound, right bound, and so -0.1, which means that's going to be the y-intercept over here, -0.1. And then next off the y-intercept, we'll go into my table. And we can see when x is 0, the y value is 1. So the y-intercept is 1, which will be the x-intercept on the inverse. All right, transformations from here to here. This 1/3 is between 0 and 1, so we're going to have a vertical compression by 1/3. We're going to go right 2 and up 4. All right, moving on, number 10. We got another solving one. And so opposite of cube root is cube both sides. So we have 4x plus 7 is equal to 64. We'll subtract 7, so 4x is equal to 57. And then we'll divide by 4 to get x equals 14.25. Again, it's always helpful to check your work, make sure you did it right. And so again, we'll go math 4, that 4th option. 4 times 14.25 plus 7. It does equal 4, so it checks. Number 11, we've got the shoulder height in centimeters of an elephant is modeled by the function right there, where t is the age in years. How old is the elephant? So that's my age, which is t, when its height is 280 centimeters. And so we're going to plug in the 280 for h. And we want to know the age, and so we're going to solve for t. So the first step would be to subtract 76. And so we get 204 is equal to 62.1 cube root of t. And then we're going to divide by 62.1, so I'm just going to divide by 62.1. So somewhere about 3.285. I'll keep 3 decimal places equals cube root of t. Then the opposite of cube root is cubing, so we're going to cube both sides. And I'll just keep this original and just cube that answer. And so my t is 35.45 years. And again, we could check this by plugging it back into the original. And so 62.1, we're going to do the cube root of, I'll just do the answer. So it brings down my answer that I got, plus 76, and it equals 280, it checks. Alright, so we're dealing with a cubic function transform using this rule. So this is the rule for my f, which is right here. So if I wanted to create this equation, it's going to become f of x equals, the 3 goes in front, x minus 2 goes in place of the x, and plus 5 goes at the end. And so this 3 is going to be a vertical stretch, because it's a number greater than 1. We're going right 2 and up 5. And again, we're solving. We got to get this exponential term by itself, so we'll divide by 5 first. So we get x plus 4 cubed equals negative 8. To get rid of the cube, we're going to cube root both sides. So x plus 4 equals negative 2. And then we'll subtract 4, so x equals negative 6. And again, it's always a good idea to check your work. And so 5, negative 6 plus 4 cubed gets negative 40. It checks. That is the correct answer. All right, so we're going to graph this function and describe the transformation. So we've got a vertical stretch by 2, left 4, and down 1. This one is a cube root function, which means it's going to be horizontal. The cube root base points from wherever I start at. When I go right 1, we're going up 1 because the cube root of 1 is 1. But this one we're going to go right 8 and up 2 because the cube root of 8 is 2. And so I'm going to start at, but this one has a vertical stretch by 2, so we're going to multiply these numbers by 2. So we're going to go up 2 and up 4 are going to be what we're actually going to do. And so we'll start going left 4, 1, 2, 3, 4, down 1. From this point, when I go right 1, I'm going to go up 2, and right 8, up 4. And it's always right from this inflection point. So right 8, up 4. And the opposite is true. I'm going to go left 1 and down 2. Left 8, 1, 2, 3, 4. And down 4, 1, 2, 3, 4. So here's my cube root graph. And it's always a good idea on your test, put this in your calculator and check and make sure that you got it correct. And last one, number 15. I'm actually going to do a couple of different 15s because I know I did a different equation for some different classes. So first period, I know we only made one change on first periods. We changed this -9 to -6. For the rest of my classes, I made another change to make it a little bit easier, and we did -2x. And then the -6 equals 2. And so you can go ahead and go to the part of the video that applies to your class. But on these, we always work our way outside in. And so I want to get rid of the minus 6 first by adding 6. So I'll rewrite everything. But adding 6 makes that 8. Now on the very outside, we have this cubed. And so we're going to go ahead and cube root both sides. The cube root of 8 is 2. So I'm going to have 45 minus 9x raised to the 1/3 plus 15 is equal to 2. And then on the outside we have plus 15, so I'm going to subtract 15. And now on the outside we've got this exponent of 1/3. To get rid of the 1/3, we're going to cube both sides. And so negative 13 cubed is negative 2197. And then we're going to subtract 45. And then last step, we're going to divide by negative 9. Which gets me x is a positive 249.1111 repeating. Alright, for the rest of my classes, it's the exact same steps as over here, except the only thing that's going to change is all these negative 9s are going to be negative 2s. And so it's just slightly going to change everything. And so the first step, we're going to add 6 over. And then we're going to take the cube root. I don't need this other parentheses right here anymore. 45 minus 2x raised to 1/3 plus 15. Cube root of 8 is 2. Then we're going to subtract 15 over to get negative 13. The opposite of having an exponent of 1/3, we're going to cube both sides. And so the negative 13 cubed is negative 2197. Then we're going to subtract 45 to get the negative 2242. And then we'll divide it by 2 to get a positive 1121. And I've already checked both of these. Both of these do check with these problems if you were to plug it back in. But I hope everybody's ready for this test that we'll be having next week.